one thing hopefully you've noticed throughout the course of the past few days we were working with these, they're all kind of the same. There really isn't like this magical factory of geometry groups out there that churns out new ones over and over and over again. Because quite honestly, we only really know anything about angle additions and segment additions. That's really all we know, and algebra. We don't know how to do any of that other stuff yet. So we start with what we can work on. It's very easy to go through. Now yesterday, the ones that we did in class, we did ones with midpoints. We did segment additions with those. We did the definition of multiplication by showing how 2 segments repeated addition was that. Things like that. That's kind of how everything goes through this first, 3-4 tries through proofs. So one of the things I've been showing people throughout the day today is that obviously you always start with your given. Please, please, pretty please with sugar on top. Whenever you have a given statement and it's something you can show on your diagram, mark your diagram. AB is congruent to BC. It's given, I throw the tick marks in. That's what I'm trying to show. After that, bless you. Remember the other thing we discussed yesterday? We discussed that anytime you do any math with a proof, you have to be within equality. You cannot do anything with congruency. There's no additive property of congruency. There's no subtraction property of congruency. There's no segment addition or segment congruency. There isn't that. So that's why a lot of times when you see that switch from congruent to equality, that means that there's going to be math involved, algebra. So why do they switch from congruent to equal? What's the reason? Addition of congruent. Okay. Now, if I'm just looking at my diagram and I'm looking at this next statement, this next statement says I have AB and BC. 2 smaller segments add up to equal to larger. Well, what is when you use 2 smaller to equal to larger? Bless you. Segment addition. 2 smaller segments add up to equal a larger one. That had nothing to do, really, I didn't even need to worry about my progression sheet for that, because I can see small segment, big segment. Small segment, big segment. Hey, I remember that. Segment addition. Yay. Yay. Okay. What changes between 3 and 4?
Substitution.
Notice how it went from AB, BC to AB, AB. Well, why did they rewrite it as AB plus AB? Because AB is BC. Anytime something equals something else, it can be replaced anywhere. So, to be honest with you, when you start seeing these written out, when you start seeing these things written out, and you see kind of the same thing written twice, but very, very close to being the same, very subtle difference, I'm going to say a really, really, really good educated guess is going to be substitution. Okay? It's always a good guess to throw that out there, because a lot of times you're going to be right. Now, yesterday we talked about what this next step was. Repeated addition is the same thing as what's that? Multiplication. What would we call it? Definition of multiplication. Yeah. It's remember, guys. 2 plus 2 plus 2 plus 2 plus 2 is 10, right? Same thing as 5 times 2. 5 groups of 2 is 10. Instead of writing it out, so AB plus AB is 2 groups of AB. 2 times AB. That's what the definition of multiplication says. And this last one is on your reason bank, but we have not talked about it. Actually, we have talked about it, believe it or not. You just probably didn't realize that we did. Let me show you this. When you have what's called the symmetric property, it means this, and you already knew this. If I call this segment XY, I could label it as XY. Do you agree? What's the other way I can write it?
Y.
property of symmetry. It's the same thing going forward and backwards. That's all it is. Anytime you see something written backwards from what it was prior to it, it's a symmetry property. Symmetric. You just write symmetric. It means the same thing as this. 3 is less than 5. 5 is greater than 3. Aren't those both true? Yeah. You know how we've done this where y equals mx plus b? Isn't it mx plus b equals y? Isn't that the same thing too? It means the same thing. When you flip-flop things on the equal signs or you rewrite things backwards, flip your letters around, it's just symmetric. It's the same thing on both sides, go in both directions. So this last one was that symmetric property. It doesn't show up a lot. I do know that it will show up sometimes with triangles because they'll say that write a triangle backwards, and that's just how you write the triangle backwards by switching the letters around by being symmetric. That's all. Okay? Not terrible. What's that? Angle. Again, you'll notice that it's kind of the exact same thing. It's kind of the same setup. If we start by just looking at what we're given, by covering up the rest of it, we'll know what we're given, we can mark our diagrams and build out of it. So if I start with what I know that angle ABC is going to be congruent to angle DEF. This one is congruent to that one. I throw my little tick marks in. And then it says the next thing is that was it angle 2 is congruent to angle 4. So I would mark that as well. 2 is congruent to 4. So I have that much. Now, they're trying to ask me to prove that 1 is congruent to 3. So, if you think about it just analytically, just by just throwing a couple of numbers in there, let's say, for example, the large angle here is 40 degrees, so which means this has to be 40 degrees, the large angle. And the smaller angle is 15 degrees, which means this one has to be 15 degrees. What has to be angle 1? It has to be 25 just by subtracting out. 2 smaller angles add up to equal the larger. So which means this one would have to be 25, which means 3 would also have to be. So what you're thinking right off the bat is that I've got 2 larger angles that are exactly the same. If I subtract out what they have in common, they both have that angles 2 and 4, which are the same. I'm going to be left with the same angle. It's just taking out that same wedge. And you're going to be left with the same amount. So what they're setting this up to use is that angled addition. They're setting up to use substitution, subtraction, things like that. Okay? But when you look at it, after they write down the givens, why do they have to switch from congruency to equality? Because you can't do one. Because you can't do what? You started to say something? You did. Because you can't do math with congruent. That's all it is. You have to be able to, when you're adding, subtracting, multiplying, dividing, it has to be in equals. Okay? That's all it is. That's why they switch it. So there's your definition. Congruent.
Are we supposed to put the symbol?
What's that?
Can you put the symbol?
Yeah, you can put symbol. I never write it out. I've only been using the symbols. If you want to write it out, by all means, go for it. Guys, any abbreviation that I use is legal. Don't make up your own abbreviations. Those are illegal. Number 3, I kind of wish, well, at 3, I'm thinking of a different problem. Never mind. In 3, they're doing 2 parts within it. They're saying that 2 smaller angles equal a larger. 2 smaller angles equal a larger by showing that 1 plus 2 is ABC. By showing 3 plus 4 is DEF. What property tells you that 2 smaller angles add together equals a larger?
Angle addition tells you that. Angle plus angle equals larger angle. That's what that shows. Angle addition is angle plus angle is larger angle. Okay? What do you think that means? Substitution. When you have two things that are equal to the other things are equal to each other. We've already said that ABC is DEF. We've already said these two are the same, which means these two have to be the same. And again,
Oh.
I'll figure out what I'm here in a second. What changes between step 4 and 5? Very subtle change. What changes?
They change angle to on the other side.
Yeah. Why can they change 4 into a 2? Because they're equal to each other, so you are using substitution again. You can use steps over and over again. Okay. You have another substitution step. What happened to the 2's on both sides? They got subtracted out. Very good. Subtract sub t prop equal. And last but not least,
I got the last one.
yeah, remember, guys, you can, there's no set limit onto how many times you can use a property or a theorem or a definition or one of them. Oh, absolutely, absolutely. Happens a lot, happens very often. Especially because right now, that's really the only style problem that we know how to do are these substitution style problems. Okay, everything kind of flows through after that, all right? Let's look at the one on the top of that page. It's going backwards. Now we're going the other direction. You're given the reasons. Let's figure out the statements. Let's go backwards. A little bit different. Some people think it's easier. So before we start into the problem, we're going to look at our givens and try to figure out what are they trying to show us so that we get the sense of what steps are going to be needed to make sure it works. Well, according to the given statement, it says that WY is equal to, or is congruent to XZ. It says that those two segments are congruent to each other. It wants us to show that the two smaller segments on the tails are the same. Well, it should be pretty obvious what you have to get rid of. What do these two larger segments have in common? XY. They've got that chunk in the middle in common. You see that? They have that chunk in the middle that's the common value. So if you start thinking about it, just real basic numerics. If I say this whole thing is 10, that means this whole thing has to be 10, right? If this middle chunk is 7, what do those other parts have to be? 3s. They would both have to be 3s. So algebraically, I'm thinking, well, I've got a chunk that's equal to 10 that's made up of something that's 3 plus 7. Then I have another chunk that's 10 that's made up of something that's 3 plus 7. Well, does 10 equal 10? So that means that 3 plus 7 has to equal 3 plus 7, which means if I drop these out, what am I left with?
3 and 3.
That's what you're doing in terms of letters, though. That's all it is. That's all that is. It's a matter of putting that together with letters, okay? So we go, oop. Clean this. So we have this part, let's get rid of this one. So we start with your given, wy congruent xz. What's the first thing you do? Take out the congruency, because you can't do math with congruent. Are W, Y, and XE the small segments or big segments?
Small.
They're the bigger segments, aren't they? Which means they're made up of two smaller segments. Equals what? Yep. WY is WX plus XY. I wish this said 3A and 3B, because then you can say XZ is XY plus YZ. Because that, the reason said, use segment addition. Well, if I use segment addition, I know that I've got two larger segments I can rewrite as two smaller segments each. What do you think we're going to substitute then? Again, we have the two larger segments that are equal. We already have these two guys equal to each other. Well, these two guys equal other things. That means these other things have to equal each other. That has to happen. And you look at our diagram, we know that these two chunks are made up to equal the larger, means these two smaller chunks have to equal each other. The large thing is 10, and the two chunks are 3 and 7, well, that means the other one has to be 3 and 7. That's why we can set them equal to each other. What do they have in common on both sides then? XY. So by subtracting out on both sides of the XY, you get WX is YZ. The only thing that I would change here would say subtraction property equal, because that's what I want you guys to write. And then what's the last step? Yeah, you just flip it back over. Okay, you just flip it back over. Because it told you to flip the congruencies. Okay. I have two of these for you guys to finish tonight. On this same page, do the one in the middle. So this is what, the page 3, do the middle one. And then on page 4, do the top one. Tomorrow we will talk about, I think I've got 3 progressions to do, and that'll allow us to do the bottom one on the 4th page, and then we'll talk about all the different theorems that are on the very front page. Okay? There aren't very many left on here that we're going to have to worry about. Then maybe we'll be able to do a couple of them that are on your own to go. Okay? Oakley. Just follow your progressions and rewatch. Every single one of these things is kind of the same. I'm not lying to you. I know that's confusing. I know it's a pain. But go back, and the more you look at a different one, it will mirror another one, because they don't really change. It's just that subtlety of noticing I've got 2 things, and all of a sudden I've got 2 things equal to other things. Those other things are equal to each other. That happens time and time and time again. That step happens all the time. It's just a matter of just seeing that repetition. So when you go and you do that, which one was it? When you go and do this 3rd one, you'll look and see what does a bisector do? Fill in, what does a bisector do? Use your progression sheet. On the back page, you've got a bunch of angles. You've got things that are equal to each other. Looks like 2 angles equaling a larger angle. things like that. Remember what that means. Two angles to be equal to a larger angle has to be angle addition because it's on the progression sheet. All right? Use that thing as your best friend in the whole wide world because it will be. Okay?